Hello everyone, welcome to another video. In this video, I'll be discussing quadratic equations part 3, and I will be discussing in this video factorizing non-monic quadratic equations and also how to expand brackets. So this video will revolve around the standard equation ax squared plus bx plus c equals 0. In my previous videos, we've just assumed a equals 1, leaving it as just x squared. Now this makes it a monic quadratic equation. Monic means 1. That's literally what it means. So that means non-monic is when it does not equal 1. So in the equations we'll be trying to solve non-monic equations where a will be bigger than 1, so it may be 2x squared plus 4x plus 6, I don't know. So let's say we have an equation 2x squared plus 6x, plus 6x plus 8 equal to 0. Actually, let me make this an 8x so it works. So 2x squared plus 8x plus 8 equals to 0. So when we have a in the ax squared bigger than 2, what we do before we use the middle term factor law is we multiply this coefficient and this. So in this situation, we would be multiplying 2 times 8. That's just how it works. So 2 times 8 equals 16. Now we can use the middle term factor law. So we have to put this b into two terms in such a way that when added it equals 8, but when multiplied equals 16. So let's go through the multiples of 16. 1 and 16, if you add them it's 17, so it's not 8. 2 times 8, if you add them it's 10, so that's not it. So that means the only one remaining is 4 and 4. So 4 plus 4 is 8x, and then if you do 4 times 4, it equals 16. So now this equation can be written as 2x squared plus 4x plus 4x plus 8 equals to 0. And now we factorize, so what can 2x squared and 4x both be divided by? They can both be divided by 2x. So we have 2x multiplied by x, because 2x squared divided by x, that just equals x, and then plus 4x divided by 2x, that equals 2, and then we add that plus what can be factorized by 4x and 8? Well, that would be 4. So plus 4 multiplied by x plus 2 equals 0. So once again, we saw that during the middle term factor law, these two terms both have to be the exact same, and that is correct. So now we can just put this in a bracket, 2x plus 4. We can put that in a bracket, so our equation then becomes 2x plus 4 times x plus 2 equals 0. So now we can use the null factor law. Now before, we haven't thought about how to use the null factor law when there is when one of the coefficients of x is bigger than 1. Well, I'm going to show you how to do that right now. So here we can already, let's just get through the equation where x equals 1, like where the coefficient of x is 1. So x equals either, so we know that using the null factor law, either this term has to be 0 or this one. So if x plus 2 was to equal 0, then x would have to equal negative 2. Pretty simple. But now here, if 2x plus 4 equals has to equal 0, then 2x has to equal negative 2. And I'll show you why. Because if we write it down as a separate equation, 2x plus 4 equal 0, then we would be bringing 4 to the other side, so 2x equals negative 4, then we would divide it by 4, so x equals negative 2. So that's the reasoning behind using the null factor law when the coefficient of x is bigger than 1. So now I hope you've understood how to use the null factor law when x has a coefficient bigger than 1. So the answer is just negative 2. Let's try and do another equation. Let me just rub this out. So let's say we have the equation 4x squared plus 10x plus 50, let's do 20 equals 0. Does that equation work? Let me just check. 18. Okay, let's just make this a 3x, and let's make this 16x. So our equation is right now 3x squared plus 16x plus 20 equals 0. So once again, we can just use one simple method, and at the very start we have to multiply this coefficient of x squared, which is 3, with the c term, which is 20. So 3 times 20 equals 60, and now to get to that 60, we need to make 16x, so the b, we have to make that into two terms in such a way that when you add b1 plus b2 equals 16, but when you add the two, when you multiply the two terms, it equals 60. So let's think about what two numbers can be multiplied to give 60. So there's 15 times 4, that doesn't work. 12 times 5, if you add that, that equals 17, so that doesn't work. 10 times 6, now that does work because 10 plus 6 is 16, and 6 times 10 equals 60. So now we can factorize this as 3x squared plus 6x plus 10x plus 20 equals 0. Oh, by the way, you need to make sure that when we put it into this kind of form, that the two can be factorized. So if we switch the order of 6x and 10x, it would be a bit more difficult to factorize. You'll still get the answer, but it'll just be a little more difficult. So just make sure that the two numbers can be divided, and don't mess around with the order. So now we can factorize what can be divided by 3x squared and 6x. Well, that would be 3x. So 3x, and then 3x squared divided by 3x, that equals x, plus 6x divided by 3x, that equals 2. So 3x times x plus 2, and then you add that with, so let's say we have 10x plus 20. What can be factorized by that? That would be 10. So plus 10 times x plus 2 equals 0. Now we see that these two terms are the same, so we can see that the middle term factor law works in this equation. And now we can fit it into the equation 3x plus 10 multiplied by x plus 2, because these two have to be in a bracket, equals 0. So now we use the null factor law, and x either equals, so this term has to be 0 or this term has to be 0. One of the two, in order, so they can be multiplied and equal to 0. So let's say x plus 2 equals 0. Well, then x would have to equal negative 2. So x equals negative 2, or, and then we have 3x plus 10 equals 0. Well, let's write that down to make sure there's no confusion. So 3x plus 10 equals 0. That means 3x equals negative 10, because we bring the 10 to the other side. And then x equals negative 10 by 3. So that means x equals -2 or -10 by 3. And there is one incredibly quick way to solve non-monic quadratic equations. So you can write them in another form, but I'll discuss that in the next video. And now we'll just be going through expanding brackets. So let me just clear this page. Excuse me. So now we'll be going through expanding brackets. So we've learned how to factorize quadratic equations, but what if we're given an equation with 2 brackets from the start and we're told to expand it? Well, let's say we have this form would be x plus d times x plus d. This is just when x plus d is like the same. In this situation, we would be making x multiplied by x and then add that to x multiplied by d, and then you add that to d multiplied by x, and then you add that with d multiplied by d. So now what we'll be doing, let's just actually go through and see what happens. Actually, instead of x plus d, I should probably make it a plus b. Just makes it easier. A plus b times a plus b. So let's say we start off with a multiplied the first term of the second bracket. So a times a, well, that equals a squared. Wait, what just happened? So a multiplied by a, that equals a squared. Then we add that to the first term of the first bracket, multiply the second term of the second bracket. So that means a multiplied by b, that would be plus ab. And then we add that to, so now that we're done multiplying everything with the first term of the first bracket, we multiply everything with the second term of the first bracket. So now we add that with b times a, and we add that with b times b. So let's say b times a, that would be ba, and then we add that with b times b. That wouldn't necessarily be b squared. It will just be like b times b, or we'll just write b squared, but that's not the case majority of the time. So what we realize here is that a times b and b times a is exactly the same thing. So this equation actually simplifies into a squared plus 2ab plus b squared equal to 0. So that is the equation we get at the very end. So let's put this to the test. So let's say something like x plus 3 times x plus 3 equal to 0. Well then, x plus 3 times x plus 3, we can see x times x is multiplied, that makes it x squared. Then we multiply x with 3, that makes it 3x. Then we multiply that again with 3x, so that equals 3x. So 3x plus 3x equals 6x. So we can already make it x squared plus 6x. And then we can do 3 times 3, which equals 9, which is basically 3 squared. So it fits the format a squared, where x equals a. 6 would be 3 times, so a and b, they're actually, so 2ab, 3 and b, a and b would actually be the same. That's why it's 6x. So this is 2ab. So it would naturally be 3x times 2. And then this 9 here is b squared. And that equals to 0. So a plus b times a plus b, that will always equal to the format a squared plus 2ab, sorry, pardon my writing, plus b squared equals 0. I should probably write down formulas for every single thing, So let me just cancel this out. So I'll write a formula for every single type of expanding brackets. So there's a plus b whole squared. And what I mean by whole squared is this entire thing is multiplied. That essentially just equals a plus b times a plus b. And the reason that is, well, let's assume it was 2 squared. Well, 2 squared would just be 2 times 2. Using that same logic, it would be a plus b times a plus b. And that would equal a squared plus 2ab plus b squared. And I've already shown how this works, so no need. And then the other one is a minus b squared. So that would equal a minus b times a minus b. So now we can factorize, we can expand. So a times a, that equals a squared. And then a times b, that equals plus a times negative b, so that would actually be minus ab, and then once again negative b times a, that would be negative ba, and then minus b times minus b, that would be plus b squared. And one thing we can notice here is negative ab and negative ba are exactly the same thing, so that would essentially be negative 2ab. So this equation is basically written as a squared minus 2ab plus b squared. So essentially in these two equations, a plus b whole squared and a minus b whole squared, the only thing that changes and the end result is the 2ab. So during a minus b, the 2ab will be a negative, and during a plus b, the 2ab will be positive. So I guess that's it for now. In the next video, we'll be discussing different types of expanding brackets, a bit more on the non-monic quadratic equations, and I'll see you in the next video. Keep on learning.